All right, hopefully you saw my outline about understanding functions before. And on my outline, I say one of the things we have to do with any function is to manipulate it. Manipulate, simplify, rewrite. And different functions have their different ways of simplifying or rewriting. Actually, there is no simplification rule for most functions. In other words, I don't know, the log of 200 isn't simplified. It's not simplified. You don't really have any rules for it. Square root has rules for simplifying, so I put that in there. But you have to be able to manipulate or rewrite a logarithm, sometimes because you're asked to do it, and sometimes to move a problem forward. But that's one of the things we're going to talk about in terms of the properties of logarithms, is how do you rewrite them? So they have a few rules here: log base 10, log base e, evaluating logarithms on a calculator, but we'll get to it. All right, so they give us a number of rules for logarithms, and by now you should understand logarithms numerically, and so you should know what this means. Log base a of 1 is saying, what exponent do I put on a to get 1? What exponent do I put on a to get 1? And the answer is 0, because a to the 0 equals 1. Same thing here. What exponent do I put on a to get a? In other words, that's what logarithm is asking. And of course, the missing number, the mystery number is 1, because a to the 1 equals a. So they're just asking you to use that numerical understanding, or use that understanding. They're not really trying to use the understanding. They're just trying to, use, well, I guess they are, scramble it, solve it, and they're kind of demonstrating that if this is true, then this is true. But I just rather you just, I don't know these rules. So they give them to you. I feel bad for students who try to memorize these, like on a flashcard or something. I mean, if that 1 weren't there, this should look like it's 1, because it's asking you, what exponent do I put on a to get a? If you've known for a long time, that would be 1. More properties of logarithms. I like to think of these as canceling. So exponents and logarithms cancel, so that cancels and just gives you m. This cancels, and it just gives you r. Now, books don't seem to like to use the word cancel, so they might try to describe this some other way. But they're inverse functions, so they cancel, and that's the kind of the main idea that you want to know. These will cancel. These will cancel. ln is log base e, just with fewer characters. And even it cancels. All right. So properties of logarithms. I guess this would be the closest thing we have to simplifying. So these were simplified, but they had multiple functions, 2 functions in them. When I said logarithms don't necessarily simplify, I just mean, log of one item, log of one thing might not have a simplification to it. But if there's an obvious cancellation, take advantage of it. All right, so here are 2 properties, one for multiplication and one for division. So what do we say? Log of a product is the sum of the 2 logarithms. And by the way, this rule is important in both directions. But log of a product is equal to sum of the logarithms and log of a quotient. This is division, is equal to the difference of the 2 separate logarithms. So they might have a, well, before we get to examples, we're going to use this one. We're going to both these quite a bit. We're going to use this one quite a bit. Well, I should say these 3, yeah. This one is an important one. This is amazing, actually. You can't appreciate until the next section how amazing it is, but this is amazing. Log base a of m to the r. So what's going on here? I'm taking log of something to a power. Well, what's amazing is I can get that r out of there and change it to multiplication. That rule is a big rule. Now, I want to remind you, you've seen something like this. I mean, don't forget that log base a of m is an exponent. It's the exponent I put on a to get m. So I'm just taking, and obviously r is an exponent because it's tiny and upstairs like this. So we're multiplying the exponents, just so you see that. All right, this is kind of a rule about E. E is sometimes called the universal base because you can always change anything into base E with this little, constant right here. So anytime you see a formula with E in it or without E in it, it could be retooled into a formula with E in it with this little trick right here. But let's look at that last one's fairly rare. I don't think we use this one to get any points on the website, but the others definitely. All right. So they're specifically telling us what to do here, and that's great. They're saying, okay, you have this with the multiplication and the exponent, and what we want you to do is write it as the sum of logarithms. In other words, stretch it out into multiple logarithms. All right, so where we had the multiplication, that's going to become addition of two separate logarithms. Now this last part, express all powers as factors. So this is obviously a power because it's upstairs. That 2 has to come out in front and become multiplication. But even this can be written as a exponent. Square root is raising to the 1/2. That was a change in itself. But even then, that 1/2 can be brought out in front and changes an exponent. By the way, I put these little multiplication symbols in here because late at night, that's going to look like a 21 to you because L, yeah. 2 times log base A. You might want to put that little dot there so you realize what the 2 is talking about. And obviously when you type it in, a lot of times students will see this late at night and they'll type in 21 OG and the computer will mark it wrong. You don't need a multiplication for it to be correct on the computer, but this is one of those really unfortunate times where a number and a letter can cost you points on a website. There's our equation or expression, and only because they're asking us to, it's not considered simplification, but they're saying, hey, write this as separate logarithms. So where there was a division, becomes subtraction of the first argument, the second argument. Where I had an exponent, move it out in front. We're done. Multiplication, multiplication. They're just getting longer. They give us a lot of examples of this, but all right. So again, where you see the division, that's going to become subtraction. Where you see the cube, we can do something there. One thing important though is where this stops. There's nothing we can do with the log base, this right here, this x squared plus 2. I certainly can't write it as, x squared plus log 2. In other words, there's nothing I do with a plus. If it had been multiplication, I could separate into 2 separate logarithms. But plus, that's going to stay there. So we're done once we've applied all of our rules. Now they're asking us to put them together. And by the way, when you're putting them together, make sure you have the same base. That's a very common mistake. If they give you one letter here and a different letter here, sometimes people will try to put them together when it just, logically that doesn't hold water. All right, try to see where these start. Okay, so there's questions. All right, so I can't put them together yet because this 3, there's no rule. I mean, that 3 has to be taken care of. It has to be put away up here. And that's exactly what they did. Now I have log of something plus log of something. Here I do. And so I can put that together into multiplication. So as weird as it looks, it might look weird, in one direction, more weird in one direction than the other. But if you have a plus, you can put it together in turn, but change it into a multiplication. So we get log base b of 40. This one, lot going on here in terms of mathematical concepts here, but logarithm concepts. This multiplication is going to become an exponent. Now, this right here, make sure we recall 27 to the 2/3 is the same as, well, the cube root of 27 squared, which is 3 squared, which is 9. So that little thing was calculated really quickly. That's 9, right? 36 minus 927. You can see where that's going. I probably would have stopped it there. ln 1/3. They couldn't resist. They went even further. ln of the first, ln of the second. But don't forget that ln of 1 is 0. So it's just going to be minus ln 3. ln 1/3, I can't imagine that being wrong in any context, any situation, but the author just took the opportunity to take this and continue. Notice what he did. While this is here, let's go ahead and say, what else the author could have done. And again, all of this looks weird in hindsight, but I just want to compare it. Let's say you didn't say, oh, look, division, let me change that to 2 separate things. But for whatever reason, you got, instead of ln 1/3, maybe you got ln 3 to the negative 1, which it is, because 3 to the negative 1 is 1/3. Taking that minus and putting it here would give you the same result. Maybe that's why the author did that extra little step, right? Maybe somebody, sometime, somewhere, took it this way and said, where are you getting this 1/3? I got negative ln 3. But this is a good example of what I said earlier. Once you've met all the check marks the author, puts your way, like express exponents as factors, there really is no simplification rules. So this should be right. Once you write it this way, I think it would be kind of weird to leave ln 1 because that is 0. So there are calculation rules. I'd calculate that, but all of these should be, or at least both of these should be fine. All right. Well, now they're asking us to take this very long thing and put it together. I'm just going to say, you should be able to kind of see what happens. All of the things that had pluses are in the numerator, and the one thing that had the minus ended up in the denominator. Yeah, that's kind of what's going to happen. I mean, feel free to go through as many steps as you need, but when you're done, it should kind of make sense compared to what you started with. Properties of logarithms. So this is kind of an idea of one-to-one functions, but if log base a of m equals log base a of m, you can conclude that m equals n, and that's going to be an important rule moving forward. Well, we'll see how we can use these properties. All right, most of us need to know the change of base rule for our calculators. So if you have a calculator that's, well, pretty much any calculator, No, there are some calculators that actually will let you type in the 4 and the 17. But you have to use the change of base rule for a calculator. And the change of base rule is log of the argument divided by log of the base. And when I say log, any log you choose, oops, I only wrote 4. I mean, that's right, but it's the base. So log of the argument divided by log of the base. Or in a calculator, maybe it's even better to write it this way. Log of the argument divided by log of the base equals. Still, there's more to this. Some calculators, you have to put the 17 first, then the log, and the 4 first, then the log. Know how your calculator works, but I can tell you it's one of these. That was divided by, okay. And what you're doing is you're just using the change of base rule. So let's see how the book writes that out. Okay. Wow. Okay. So the author took a long time to get there, but okay, I don't know if you remember the question. I guess I was trying to show you why it's ln 17 divided by ln 4. But, you know, that's what we had. Log 17 divided by log 4. Don't do this anytime you're trying to use a calculator. Just use the, well, here it is, change of base formula. So the author was trying to ease us into the change of base formula, I suppose, there. Here it is. I don't really like it written this way for a calculator because, you know, yeah, this is how you write divisions when you're not using a calculator, when you're not using a calculator. But when you are using a calculator, you would, you know, write it across in one line. Log base 10, log base e, actually any base you choose, but because calculators typically only have those 2 buttons, we would use this. All right, so how do you do this on a calculator if your calculator only has log and ln? Well, you change it to one of those. So that's what they did. Log of the argument divided by log of the base, log of the argument divided by log of the base. Doesn't matter which one you choose as long as you use that consistently. Same thing, log of the argument divided by log of the base, and gives you the logarithm. By the way, these are very, very accurate. It's kind of almost, you know, surprising how accurate it is. Because every once in a while you might do this to something that you wouldn't need a calculator to calculate. What I mean by that is if you used a calculator to do this, log base 2 of 8. Now, hopefully by now you don't need a calculator for this because you know the exponent you put on 2 to get 8 is 3, right? It's asking this question. But if you were to say, oh, I'm going to do ln 8 divided by ln 2, if you were to look under the hood, meaning if you were to actually look at what that calculation is, it's a terrible number. It's a decimal point, goes on forever. It's a you know, irrational number, you know, with an infinite decimal place. So is that. But you take those 2 numbers and divide them, and it's precisely 3. So whether you get the answer directly or with your calculator, nobody would know because it's the right answer. All right. Now, I have said log of the argument divided by log of the base so many times that I actually have a group of students who overuse this. Now, nobody's watching over your shoulder, but let's say I wanted to use a calculator to do log base 10 of 1,000. Now, no secret, your calculator has a log base 10 button. So hopefully you're embarrassed 3 times by using your calculator for this question, all right? Because remember what it's asking. It's asking what exponent would I put on 10 to get 1,000? And the answer is going to be 3. I don't care how you do this. It's going to be 3. But let's say you're not that confident with logarithms, and so you say, this would be the first embarrassing way of doing this problem. Let's say you said, I'm going to use my calculator, log 1,000. And you tap it, and you get 3. And then you kind of, hit yourself in the forehead and say, oh, I should have known. But I just want to talk about these students I've had who have over-calculated this way. And you think I'm joking, but I've actually seen students do this, right? They say, oh, yeah, the base is 10. So I have to do log of the argument divided by log of the base. Okay, maybe this looks ridiculous. Maybe they use the ln button. Well, no. I'm going to leave it this way. ln doesn't really show the... that would work, by the way, if I use the ln button. But what's weird about this? Why do I find this embarrassing? All right. Well, this is a calculation you could do in your head because it's asking you what exponent you put on 10 to get 1,000. All right. And then you're using your calculator to answer this question, which is also a question you should be able to do in your head. What exponent do you put on 10 to get 10? One. And then the reason why I say this is triple embarrassing is you're using your calculator to do 3 divided by 1. 3. Now, not that much harm was done in this process. If you just always do log of the argument divided by log of the base, even if it's base 10, I suppose that's fine. But just when you kind of look at what you're doing, it kind of is embarrassing because you're dividing by 1. I'm not going to take that away from you, though. If it helps you with one rule, just memorizing one rule, and you're not having to stop and think, that's fine. But change of base rule, it's how we do our calculations, and we just need it. We need it to make, to get our calculations for something like this. And we don't need it. We don't need to change the base if the base is already 10, but it still kind of works. So I'll leave you with that. That's the end of this section.